doing lesson 10.6, Application of Logarithms. And in class, you're going to learn how to use a calculator to find base 10 logs. So that could be anything where it says log base 10 of 5 or 2.16. It doesn't matter. There's a way to find those type of logs on your calculator. So what I'm going to focus on is how to solve some of these problems so that they're in what's called calculator ready form. So let's do our first example. Example number 1. If I give you 3 to the 2x equals 5, back in chapter, I think it was 10.4, or maybe it was earlier, you needed to make sure that you tried to get 3 and 5 the same bases so that you could cross them off and just solve for x. But there's no way that I can make a 3 and a 5 the same base. There's nothing I can reduce down to make it 3 squared or 2 squared that's going to give me a 3 or a 5. So I can't use that rule. I had to use a new rule. And whenever you come into that problem, you can take the log base 10 to both sides of the equation. So what I did is I just took the log of both sides, and now I can look here and go, okay, I'm going to use my laws of exponents that we learned in 10.5. I'm going to go ahead and I'm going to move this 2x to the front, so I'm going to have 2x times log base 10 of 3 to the equals, and then log base 10 of 5. So all I did was move the 2x down to the front. Now I'm going to go ahead and try to get x by itself. In order to do that, I'm going to divide by 2 and by log base 10 of 3 to both sides. So I'm going to solve for x here, 2. So the 2's will go away, the log base 10 of 3 will go away, and I will have x equals log base 10 of 5 divided by log base 10 of 3. Don't forget the 2, I keep forgetting that 2. So this is what's called calculator ready form. And eventually you will have to find what the log base 10 of 5 is and what 2 log base 10 of 3 is in your calculator, and you will divide those two decimals to get a decimal answer. So if it asks for your answer in calculator ready form, you're done once you get x by itself. If it wants the decimal, you have to find what this one is and what this one is and divide those answers to get a decimal. And we can do that in class tomorrow. Let's do example number 2. I'm going to give you 1.02 to the x equals 2. Now, there's no way I can make this decimal 1.02 and 2 common bases to cross them off to solve for x. So I'm going to take the log base 10 of both sides. Now I'm going to go ahead and move that x to the front because that is my exponent. And I'm going to go ahead and solve for x. So I'm going to divide by log base 10 of 1.02. This will go away. I'll have x equals log base 10 of 2 over log base 10 of 1.02. Again, you will have to find what the log base 10 of 2 is and what the log base 10 of 0.02 is in your calculator. Divide them and get a decimal answer. But but if it's asking for calculator ready form, this is your final answer. Let's go on to something new. There's another formula. This is the last one. It's the change of base formula. It says if you have a log base a of x, let me write it out and then I'll show you how this kind of works. Okay. If you notice, b is the same. This has to be, b has to equal base 10, okay, in order for this to work, in order for you to put it in your calculator. So a, this little a, goes on the bottom. It'll be log base 10 of whatever that base is. And in green I'll do this. This x has to go on top. It'll be log base 10 of whatever x is. Here's when you use this formula. If I gave you, and let's make this example number 3, if I said find log base 4 of 7, and if you remember in chapter, I think it was 10:4, you set it equal to x, and you did this little circle thing where it's 4 to the x equals 7, and you look and you go, oh, I can't find like bases, so I can't solve this. So there is a shortcut where you can use the change of base formula, and it's this right here. So I could make it log base 10 over log base 10, because remember I said that b has to be 10. And remember the green goes on top, so this would be 7. And the yellow a for your base goes on the bottom, so this would be 4. So all you'd have to do is log base 10 of 7 and log base 10 of 4. And you would be done. This makes sense because can't I take the log of both sides here? Well, sure, I can make this log base, I could take the log base 10 of 4 to the x equals log base 10 of 7, because you're taking the log of both sides. I would put the x on in front. And I could divide by log base 10 by 4. So x would equal log base 10 of 7 over log base 10 of 4. And that's the same thing here. So this is just a shorter version of what we would be doing with taking the log of both sides. The last example I want to do, and I think this is number 4, and it's really short, I'm just reminding you that if you have x to the 2/3 power equals 12, if you remember, I think it's back in chapter 10 whenever your variable is your base number, you multiply this by the reciprocal to both sides. These would cancel out to 1, and you'd have 12 to the 3/2. All you need to do is in your calculator, and we can show you in class, is just to take 12 to the 3/2 power. And if you do that in your calculator, you should get 4.1.